Alright guys, hello everyone. So today we are going to cover lesson 4.4 and 4.5, and I'm going to start off with lesson 4.4. And this lesson we're gonna learn how to evaluate logarithmics, alright, and change of base theorem. But to be honest, I'm not gonna use this theorem basically, and I'm gonna show you a super cool way, everyone. Alright, let me show you how it works. Again, we're not gonna use this much, we're gonna just learn how to evaluate, and there's a super tricky way, right? Let's have a look at this one, guys. To find this logarithmic, we can use this like long way, but I don't wanna use it. We're gonna use calculator. Alright, everyone. And we're going to use Desmos, our best calculator ever, Desmos. Alright, so we're gonna do this, and let me go to Desmos first. Let me go to Google, let me go to Desmos, start graphing, and click on this keyboard here, and you should go to functions, and then over here you should go to very last one over here and go to logarithmic here and type whatever you have here. My question was 10 to the power -5. So if you just type it up here, we seen that answer should be -5. That's all what we do in this lesson, -5. And we are done with this one. Alright folks, let's say on this one, logarithmic 0.001. Let's type it up again. So let me, again, I will go to, again, functions, go to this one, logarithmic 0.001. Yep, here we are. So we see that answer should be -3. But that's how we do those. Nothing hard, nothing difficult, just type it up and see the answer. Okay, and logarithmic 97, so we just here again, so you can just type it up 97, so it should be 1 point, copy paste this, so here we are. So that's my answer. That's all what we do. All right, we can see this right here. Okay, so I believe that's super easy. So let's say that even if we see something logarithmic 355 times 29, no, they are fine, just type it up as we've seen it. So we're gonna do this, 355 times, what was it, 229, 29. Here we are, super cool. Just type it up, see what you got. That's all what we do on this lesson 4.4, guys. Here we are. That's it. That's my answer. That's it. Even if you're using a division here, find the value of this logarithmic, I'm gonna do the same thing. Type it up, 520 divided by 349. What was the number? 520 divided by 349. 349. Here we are. That's all what we do. Alright guys, I'm not gonna even do this one. Let me see. Again, like you can, okay, let me show you those. I don't want to skip that. So even if we're seeing something like this, like sum of two logarithmic, I'm gonna do this, I'm gonna find the numbers, and then I'm going to add them up then. Logarithmic 330 should be 30. Or we can even do this. Let's put that plus here, and let's just keep going. Function logarithmic 330 44. Let's put it here 44. We can just see the final answer, and we are good. Here we are. I'm not gonna even just find them one by one. You can even find them one by one, add them up, but let's just use calculator. That's all. Like here, sometimes we have a base here. Like most of the time, we are not given a base. Like as you've seen, those are like empty down here. But sometimes we are given some bases, but nothing else, nothing new. Is same way. Logarithmic base 3 is 6. I'm gonna do this. I'm gonna go to scheme calculator here. Let's go to functions. Let's go to this one, and we should click on this one this time. My base is 3 and 6 over here, and we can just see the answer clearly. All right, here we are. We got the answer. All right, so let's say even on this one, just same thing. Logarithmic base 7. Here we should have 0.57, and that's my answer. Yes, so let's take a screenshot so we can see the answer clearly. And yep, here it is. That's all, guys. All right. So let's move on to lesson 4.5. On lesson 4.5, we're going to work with exponential and logarithmic equations everyone. And this is the last topic of chapter 4. So as you've seen, like we've seen those rules previously on like last week, like those rules. If we see addition, that refers to multiplication. If we see subtraction, that refers to division. And if we see exponent, we can move him to the very front, right? And also, I just add these two new rules, guys. And if you've seen that, like it could be any base, and 1, it should be equal to 0. And if you see same numbers over here, that should be equal to 1. And in terms of those, I would love to show you a few examples. Like let's say we got logarithmic base 5, 1. So it should be equal to like 0, guys, right? Even if we have something like this, logarithmic base 22, 1. So it should be equal to 0 as well. Whatever you done here, it doesn't matter. As long as you have 1 here, it's going to be equal to 0. And on this one, if we got those numbers same, so it should be equal to 1. Let's say logarithmic 5, 5 should be equal to 1. Or let's say you have logarithmic like 10, 10, so it should be equal to 1 as well. Even if we have logarithmic 25, 25, so it should be equal to 1. Those are like new rules for today, okay? Same numbers equals to 1. If you see whatever here, it doesn't matter. As long as you have 1 here, so it should be equal to 0, guys. Let me show you my first equation, first question. But so far we solved these kinds of exponents, but they were the equations you can write in same basis. But those kinds of questions kinds of harder, and you won't be able to write them in same basis. That's why we are going to use logarithmic here. I'm going to do this. I'm going to take a logarithmic of both sides here. I'm going to do this. Logarithmic 7 to the x power is going to be equal to logarithmic 12. Careful, just put the logs on both sides. And then as we know here, if we see exponent, we can move him to the front. As like remember here, this r comes to the front, right? So the exponent will come to the front. So it's going to be x logarithmic 7 equals to logarithmic 12. Okay, so I know those numbers. I can find them on the Desmos on calculator. So let's see what log 7 is. Also, let's see what we got on log 12, and we can find those values. So log 7. Let me go here. Log 7 should be equal to, here we are, 0.845. So I'm going to take this 0.84. Alright guys, I'm going to take it as a 0.84. I'm going to just round it. 0.84 Let's see log 12. Log 12 is what? 12 is, now this one we can take 1.07. So 1.07. So lastly, to find x, if I divide both sides by 0.84, so I can see my x value. X equals to, let's go to decimals again, 1.07 divided by 0.84. So as you see, my answer should be 1.27. 1.27. But those are like roughly numbers. So I want you to know that those are like roughly. Right? Because I didn't take the whole numbers here. I didn't take the whole numbers here. Estimatedly, so x should be equal to this one. So let me show you one more example. A similar example, right? Like 5 and 90. It's impossible to write them in the same basis. So I'm going to take logarithmic of both sides. It's going to be logarithmic 5 to the x power equals to logarithmic 90. And then this x goes to the front. X times logarithmic 5 equals to logarithmic 90. Let me find this number, let me find those numbers. Logarithmic 90 should be 1.95. 1.95. Let me see, logarithmic 5 should be 0.69. 0.69x here. So if I divide both sides by 0.69, these two will cancel each other. I'm gonna see like x roughly is going to be, let me see, 1.95 divided by 0.69. We can see that it's going to be 2.82. 2.82. That's going to be my answer here. Make sure, guys, like at this point, I want you to pause the video and try to solve these two examples. So let's move on to example 2, part 2 of this lesson. What if we seen something like this? Okay, like we got 3 to the power 2x minus 1, here 0.4x plus 2. This is a kind of hard question, but we're going to use the same way. We are going to take logarithmic of both sides. 2x minus 1 equals logarithmic 0.4x plus 2. As I told you earlier, those exponents should go to the front, everyone, right? So this one should be what? This one should be 2x minus 1 goes to the front, and logarithmic 3 equals to x plus 2 goes to the front, and logarithmic 0.4. Let me see those values. 2x minus 1. I'm going to see this value, x plus 2, and then logarithmic 0.4. Let me check those. Logarithmic 3 should be, logarithmic 3 is 0.47. Let me put here 0.47. And on this side, logarithmic 0.4 should be negative 3.39, negative 0.39, negative 0.39. I'm going to do this. I'm going to distribute them over parentheses, everyone. Over parentheses. Okay, so 0.47 times 2 should be 0.94. X minus 0.47 equals to negative 0.39 times x, negative 0.39x, and minus 0.39 times 2, 1, 0.78. So at this point, we're gonna just solve for x. Basically, we will try to get x along here. So let's add 0.39x to both sides. 0.39x to both sides. So these two will cancel each other. On this side, we got what? We got one more 30. And 1.33x minus 0.47 equals to negative 0.78. So at this point, we're going to add 0.47. We're going to add 0.47. So these two will cancel each other. So 1.33x equals to, on this side, we get what? Negative, negative 0.31. So lastly, we should divide them. 1.33 both sides. 1.33. These two cancel each other. X equals to negative 0.31 divided by 1.33. So let's go to calculator. Let's see what we got. 0.31. Let's see. 0.31 divided by 1.33. So as we've seen, answer should be 0.23. 0.23 roughly. Okay, that's roughly. On the next example, I'm gonna show you one more example. I'm gonna show you this one, but I want to try this one. So to solve this one, as I show you, just take logarithmic of both sides. Logarithmic 2x plus 3 equals logarithmic 5 to x. Again, exponent comes to the front. Exponent comes to the front. So we got here x plus 3 times logarithmic 2 equals 2x times logarithmic 5. So let's see this logarithmic 2 and logarithmic 5. Let's see what we got there. We're gonna find logarithmic 2 here and x plus 3. Let me bring it down. So logarithmic 2 should be equal to logarithmic 2, 0.30. So we can make it 0.3, which is the same thing. Equals to logarithmic 5 should be 0.69, but to make it easy, to make it more understandable, I'm gonna go with 0.7, okay, which is super close, 0.7. Let me put here 0.7 times 0.7. So on this side, we should get what? 0.7 times 2, 1.4x. On this side, let me distribute 0.3 times x, 0.3x, plus 0.3 times 3, 0.9. Let's just solve for x. So let me subtract 0.3x from both sides. Let's see what we got. These two will cancel each other. 0.9 equals to 0.9x. So it should be equal to 0.9, 0.9. These two will cancel each other. X should be equal to 1 here. Okay, but this is not 1 exactly. This is going to be like roughly 1. So like if we get to like here 0.6989, I believe answer should be 1.10 blah blah blah, something like this. It's not exactly 1, but it's super close to 1. Okay, at this point I want you to have a try this example, everyone. And then right now I'm gonna introduce you a few new things here. Like first of all, this E is a special number. Okay, but there's a like big story behind this, how you get it, like where it's coming from. But to make this video short, it's like this number. It's the kinds of pi. It's an irrational number, but that's a special number. Okay. And now I'm gonna show you this one as well. Like this is ln x. It's like another logarithmic function, but that's not something new. If you have like base of logarithmic e, this function is going to be like ln x here. Okay, folks, it's not like something new. If you have base of e, so that function, that logarithmic is going to be ln x logarithmic. And like this, like kinds of new rule, ln e always going to be equal to 1. Alright, so let's do a few examples. Solve this equation. So to solve this one, like I'm gonna do this. I'm gonna like we're done taking logarithm of both sides. This time I'm going to do with ln e x squared and ln 200. Like again, exponent always comes to the front. My exponent was x squared and ln e equals to ln 200. We just seen that ln e was 1, right? So it's here, ln e is 1. So it's just gone, right? So we have x squared equals to ln 200. To see this, let's go to calculator again. ln 200. Now here, if we go to functions again, if we go to this one, like we use ln here, ln 200. So it's going to be 5.29. So let's go with that. It's going to be 5.29, like more or less, right? And lastly, to find x, if we get the square root of both sides, we can see the x more or less. Approximately 5 square root of, oops, let's go to new one, square root of 5.29, which is 2.3. So x equals 2.3. So that's my answer then. Okay, let me do this one as well. So in this one, like same thing. If you see e, it's make more sense to take ln of both sides. ln e 2x plus 2 ln 10. Yeah, exponent comes to the front. 2x plus 2 and ln e equals ln 10. We know that ln e was 1. It just got. We have left 2x plus 2 equals ln 10 here. So let's find ln 10 then. ln 10 should be equal to, let's put it here, 10, 2.30, more or less. Let's go with 2.3 then. 2.3. 2.3. So let's solve for x. Minus 2 minus 2. These two will cancel. 2x equals to 0.3. So lastly, if we divide both sides by 2, we should get x equals 0.15. So that's my answer there. Alright folks, that's how we do those. And then, like this is, oops, so much. This is, oops, your turn example. Make sure I want you to have a try this. Alright. So before we move on to next part, I want to remind you this. Like how do we convert logarithmic to exponents? Alright. So like logarithmic base 2 to the 8 equals 3. Like always, this one is going to be base. This number comes to the exponent equals to this middle number. Alright. That's how we convert them. We've seen this on the previous lesson. So let's say we want to solve this one. Okay, we're gonna do this. So first of all, this ln should be alone, which is not, right? So let's divide both sides by 7 first. These two will cancel. ln x equals to 4. As of right now, I knew that ln x was what? Logarithmic base ex, right? It was ln x equals 4. So as of right now, if I convert this to exponential form, I can see x easily. So e to the 4th power equals x. So x should be equal to e to the 4th power. So let's go to decimals. Let's see e to the power 4. If you type it up here, it's going to be 54.59. So we can just 54.59, more or less, right? That's how we find it. So also let me show you this one as well. Like here, logarithmic is alone, so I'm ready to go further. It's a logarithmic. Let's convert this to exponential first. So it's going to be 2, like that's my base, to the third power equals the middle number, which is up here, x cubed minus 19. We know this number, 2 to the third power, 2 times 2 times 2, which is 8, equals x cubed minus 19. So let's do plus 19 plus 19. So x cubed is going to be 27. So x should be equal to 3. That's my answer. Okay. On those examples, I'm not gonna finish them, but I will start them, but I want you to do the rest. Alright, folks? Like on this one, 3 is alone here. So let's divide both sides by 3 first. 3 we cancel each other. So ln x equals 9 divided by 3 is 3. ln x was what? Logarithmic x was equals 3. So at this point, convert to exponential form so you can see the answer. Okay, convert to exponential form and you can see the answer. On this one, like you can just, let me change my color, just convert to exponential form. So ln was what? Logarithmic 2x equals 5. So if you convert this to exponential form, e to the 5th power equals 2x. So calculate this number, right? And then divided by 2 can give you x here. Okay. And lastly, on this one, we can do what? Make sure you finish this, folks. Finish this. On this one, if you don't see any base here, which means there's like base of 10 here, there's a kind of rule. Okay. So let's convert to exponential form first. We can see this easily. So 10 to the power 0.7975 equals to 3 minus x. So just go to calculator, find this number, and then do the basic algebra to see x everyone. Please make sure to stop the video and try those. Okay. So last part of this example, this lesson is going to be those examples. I'm going to solve this one, this is going to be yours, and we're going to be done for today everyone. So logarithmic x plus 6, x plus 2, logarithmic 3. Okay, I just changed the question a little bit. This is logarithmic 3. So I want to remind you this. So if we had a, oops, not there. Let me find this first. If we had like subtraction here, which means it's a division. So which means like here, I should divide those. So it should be logarithmic x plus 6 divided by x plus 2 equals to logarithmic 3. So since like we have logarithmic on both sides, we can kind of like cancel them out. So we have left kinds of x plus 6 divided by x plus 2 equals to 3. So, and then let's just solve for x here. 3 we can write as a 3 over 1, and then let's cross multiply. X plus 6 times 1, x plus 6 anyway, and this side 3 times this. So 3 times x, 3x, 3 times 2 is going to be 6. So it's going to be, oh my goodness. Okay, it's fine, it's fine, it's fine. Very good. So subtract 6 from both sides. They cancel each other, they cancel each other. 3x equals x here, right? So here, I want you to see that, like, since I just make up this number, that's why we didn't have a proper answer, but here you can see that x should be equal to 0 here, right? Like plug in 0 here, 0 plus 6, 6. 0 plus 2 is 2. 6 divided by 2 is 3. Like we can see 3 is work. So 0 is working here well. X is 0. So we can see that one. And x is 0 here. So that's my answer here then. Right? Because like 0 here, 3 times 0 is 0. 0 equals 0. So it's working out. Alright. So I want you guys to have a try this one, and we are going to be done with for this lesson. Alright. Thank you so much for listening. Have a good one.